Okay, so in this video we're looking at atomic number and relative molecular mass. Hopefully this one should be fairly straightforward. A lot of it's very similar to GCSE. So first, be able to use the periodic table to find the atomic number or relative atomic mass for an element. Now most periodic tables have actually got this key on them, so that should be fairly straightforward. So for example, if I pick sodium out, and sodium 11 and 23, your atomic number is always the smaller number. It's usually the bottom one. So that's that. And the atomic number by definition is the number of protons. And then the top number up here is the relative atomic mass, just to be precise. And that is the protons plus neutrons. So being able to use a periodic table to find them, just be able to pick them out. So if I ask you what's the atomic number for sodium, you give me this number, not that one. Be able to determine the number of protons, electrons, I would have thought that should have said neutrons as well, and an atom or ion. So protons, just your atomic number. Just for the sake of completeness, if I want to work out neutrons, all I would do is top number subtract bottom number. So 23 minus 11 equals 12 neutrons. Now, when an element is neutral, so we are just looking at the atom there, and no charge, then protons, so when neutral, protons equals the number of electrons. It is only when we've got a charge introduced, so either a positive or negative charge, that our number of protons and electrons are different. So the protons in this case, still 11. But it's got a positive charge. So what this means, it has lost an electron. So electrons are negatively charged. If you lose the negative charge, you become more positive. Essentially, this is saying we've got one more proton than electrons now. So if I've got one more proton than electrons, then the electron now must be 10. And just one more example. So if I pick the oxide ion, so protons here be 8, bottom number again, not the top one. 2 minus charge, negative means it picked up 2 electrons. So essentially what this is saying is you've got 2 less protons than the electrons. My electrons now, and in this case, just a coincidence that they're the same with what I've picked up the top of my head. So be able to calculate the relative molecular mass or relative formula mass of a compound from the sum of the relative atomic masses of all the atoms present. So it could give you something like, I believe this was an exam question in the past, ammonium chloride, and it wants you to work out the relative molecular mass of this. Now all you need to do, each of the individual species within here, you look at the periodic table. So nitrogen is 14, hydrogen is 1, and chlorine 35.5. So look at the periodic table. Any decimals, you still need to include them. Nitrogen, I've only got one of these, that's 14, but I've got 4 hydrogen, so I need to do 4 lots of 1 there. Again, 1 chlorine, so 1 of those. What I would do is 14 plus 4 times 1 plus 35.5 Long day, I'm going to use my calculator and be lazy. And that gives us a relative molecular mass for the ammonium chloride of 53.5. So nice easy mark in the exam this. You're basically just doing a little bit of addition arithmetic based on what you've looked at the periodic table.